Hello students, hope you are doing well, and I also hope that you remember what we studied in the last video. Do you remember? We studied about graphical representation of motion. So what are we going to do today? Today we are going to learn three equations of motion, and we are also going to use graphical method to prove these relations. Basically, we will be deriving one equation and rest of the two we will be doing it in the next video. So let us start. As I said, we are going to continue with the lesson motion, which is chapter number 8 of our textbook. In particularly, we are going to discuss about equations of motion by graphical method. So starting with the topic, the few things that we should consider. When an object moves along a straight line with a uniform acceleration, it is possible to relate its velocity, acceleration during motion, and the distance covered by it in certain time interval by set of equations known as equations of motion. So what are equations of motions? Equations of motions are nothing but equations that relate velocity, acceleration, distance, and time with each other. Let us see these equations. So this is our equation number 1, which is V is equal to U plus AT. Second equation is S is equal to UT plus half AT square. And third equation is 2AS is equal to V square minus U square. This third equation can also be written as V square is equal to U square plus 2S, because when we take this U square on left hand side, it becomes plus U square. So V square becomes U square plus 2AS. So equation 1, which is V is equal to U plus AT, describes velocity time relation. Then equation number 2, which is S is equal to UT plus half AT square, represents or describes position time relation. And the last equation 2AS is equal to V square minus U square represents relation between position and velocity. The fact is, we can derive all these three equations by graphical method, out of which the first equation we are going to derive today. Let us consider a velocity time graph of an object that moves under uniform acceleration as shown in the figure. So this is our figure. Note that here initial velocity is not equal to 0. Let us name it as U. It starts from point A. So let the initial velocity of the object be U. Then it goes on increasing until it reaches V. So this has increased until here. So V is the final velocity. And this has happened in a time interval t, small t. This velocity changes at uniform rate. Let that rate of change in velocity be small a. Let us move this graph aside and let us start with the derivation. In this graph, the perpendicular lines BC, where is BC? Over here, can you see it? And BE, can you see BE? BE is over here. So these two lines are drawn from point B over here, so that the initial velocity is represented by OA. Can you see O? Over here, this is O and this is A. So OA represents initial velocity and the final velocity is represented by BC. So this entire line represents final velocity. And the time interval T is represented by OC. So O until C represents time interval. Let us analyze this graph. Here, can you see BD? Yes, this BD is nothing but BC minus CD. So BD is equal to BC minus CD. This difference represents the change in velocity in time interval T. So where is time interval? It is represented by OC. Now we draw AD parallel to OC. So this ADCO as you can see is a rectangle. From the graph we observe that, let us move this above and continue with the next part. This BC, where is BC? This over here. BC is equal to BD plus DC. So what is BC? BD plus DC, correct? Okay. Now can we write, instead of DC, can we write OA? Yes, why not? Because they are rectangle and we already know that opposite sides of rectangle are equal. So instead of DC, we can write OA. And why? Because DC is equal to OA. Now, substituting BC is equal to V, because BC represents final velocity, and OA, where is OA? Over here. This OA is a initial velocity, that is U. We get V is equal to, so instead of BC we are writing V, and instead of OA we are writing U. So V is equal to BD plus U. Now with a small adjustment, keeping BD as it is and moving U to the left hand side, we will get BD is equal to V minus U. So BD is equal to V minus U. Now let us move this equation above and move on to the next relation. BD is equal to V minus U. Let this be equation 1. Remember this equation because it will be used in our derivation in future also. From velocity time graph, the acceleration of the object is given by A is equal to change in velocity upon time taken. That is the definition of acceleration. Acceleration is defined as rate of change of velocity with respect to time. So change in velocity upon time taken. So what is change in velocity? Change in velocity is BD, because BC is a final velocity and this DC or OA, which are same, represents initial velocity. So final velocity minus initial velocity is nothing but BD. So BD upon time taken will be represented by AD, because AD is equal to OC. So we can write BD upon AD. We can also write it as BD upon OC. Fine. Let us move on to the next relation. Let us move this above. Okay. Now here OC is nothing but time taken. So we have to substitute it. So A is equal to BD upon T. Now keeping BD at the same place, you have to move T to the left hand side. But when T moves to the left hand side, it will go to numerator, because here it is at denominator place. Here it will go to numerator. So BD is equal to AT. Understood? So BD is equal to AT. This is our second equation. So both the equations, equation 1 as equation as well as equation 2, we have to remember. Now what next? We have to use equation 1 and 2. What was equation 1? Equation 1 was over here. BD is equal to V minus U. And what was equation 2? Equation 2 is BD is equal to AT. Now if we replace, instead of BD, if we replace it by AT, we will get V is equal to U plus AT. So that becomes our final answer, and this is our first equation of motion. V is equal to U plus AT. So what we have to do? Use equation 1 and equation 2 and derive this relation V is equal to U plus AT. Understood? I hope you have understood this equation, but if you have any doubt, please feel free to ask me anytime. Now let us move on to the assignment. Today's assignment has 2 questions. First is state 3 equations of motion. So you have to write all the 3 equations of motion. And second one is derive velocity time relation using graphical method. So just now we studied how to derive V is equal to U plus AT. That same relation you have to derive in your notebook also. So these are the two equations for today's assignment. Well, that's all for today. If you have any doubts, please feel free to ask me. Okay, see you in next video. Until then, take care. Bye bye.